Hi, welcome to our cave laboratory at ISPAG in Zurich. My name is Sina. In this short training video, I will show how easy it is to measure the dielectric properties of thin samples and liquids with DAQ-TL2. DAQ-TL2 is the second generation of our instrument for dielectric assessment of thin layers and includes important improvements compared to the first generation. It is still based on the same open coaxial DAQ-TL probes, but the stainless steel platform has been replaced by a lossy material. The use of this lossy platform, combined with the novel and powerful direct solver developed by the ETIS Foundation, eliminates the unwanted distorting resonances and compensates for the air gap formation between the probe and the sample. In other words, we are able to reduce the measurement uncertainties, in particular with respect to the high permittivity materials. In addition, the platform is bearing on a single sphere and therefore automatically aligns the surface of the sample with that of the probe, ensuring optimal sample-probe contact. The DAQ-TL2 system comprises the following components: DAQ-TL2 base system, one or more of the following probe beams with the matching color-coded lossy platform. DAQ-TL2 12, covering from 4 to 600 MHz. DAQ-TL2 3.5, covering from 200 MHz to 20 GHz. And DAQ-TL2 1.2e, covering from 5 to 67 GHz. DAQ-TL2 CalSet, including set of reference load materials with various thicknesses: EcoStock, Teflon, alumina, and boron nitride. Set of thickness gauge blocks: 0.5, 1, 2, 5, and 8 mm. Set of copper shorting strips, one metal Petri dish, and one aluminum top plate for liquid measurements. Let me demonstrate how to set up the system. First of all, I have to decide which range I want to measure. I select DAQ-TL2 1.2e and mount it on the base unit. Now I connect the probe to the VNA port and switch on the base unit. As you can see, the VNA is placed on top of the support to minimize bending of the cable, connecting the probe to the VNA. This VNA stand is part of the delivery. The status of the system is indicated by LED lights. The two LED lamps underneath the probe beam are lit red. Red means that the system is waiting for the safety switch test and the thickness measurement zeroing. I quickly detach both safety covers. The color of the two LEDs changed to yellow. Next, I reattach the safety covers. The sample platform moves up until it touches the probe and it goes back to the zero position. The base unit initialization process ensures that the thickness measurement system is precisely zero and checks that both RFID safety switches are operational. After hardware initialization, we need to run the DAQ software. The first step is the VNA configuration. The DAQ software uses VISA standard libraries to communicate with the VNA. I just need to copy the VISA address from NIMAX into the VNA section and click on the Connect button. I set the source power to 0 dBm and IF bandwidth to 100 Hz to minimize the VNA noise. Next is the probe selection. Here I have DAQ-TL2 1.2e probe mounted on the base unit. I need to select the probe from the list and define the frequency range. For a fast and accurate measurement process with enough data points, we recommend the following frequency setup for all three probes. For DAQ-TL2 12, from 4 to 9.5 MHz, we use 0.5 MHz resolution, and from 10 to 600 MHz, we use 5 MHz resolution. For DAQ-TL2 3.5, from 200 to 295 MHz, we use 5 MHz resolution. From 300 to 6000, we use 50 MHz resolution, and from 6250 to 20 GHz, we use 250 MHz resolution. For DAQ-TL2 1.2e, from 5000 to 6000 MHz, we use 50 MHz resolution, and from 6250 MHz up to 67 GHz, we use 250 MHz resolution. Here on the right side of the DAQ software GUI, in the setup mode, you see the dielectric material section, which includes target data values for different reference materials. These data are used during load calibration and also to observe the deviation of measured data from target values during the measurements. It is possible to import any desired data simply by clicking on the Import button. After setting up the system, the standard open short load calibration must be performed at the surface of the probe prior to the measurement. The reference plane of the S11 measurement is shifted to the probe flange after application of calibration. For solid measurements, I perform the calibration according to the following steps. Step 1. Measurement mode is set to solid. Step 2. The suitable load material is selected from the drop-down list. We use EcoStock for low permittivity and Alumina disc for high permittivity samples, for permittivity bigger than 10. These materials have well-defined dielectric parameters that are frequency independent over DAC-TL2's entire frequency range. In addition, the discs have polished surfaces that make good contact with the probe flange. Step 3. I start the calibration procedure by pressing the Calibrate button. Step 4. I make sure that the stage is fully open by pressing the Open button in the base system controller. Step 5. When the platform stops moving, I click on the O calibration button in the GUI. An ideal open circuit is the rightmost point of the Smith chart. Step 6. For an accurate and repeatable short measurement, I polish the copper tape with a fine sandpaper and clean the polish tape with isopropanol alcohol before use. I place the short tape on the lossy platform through the openings of the safety covers. I click on the Close button to bring the shorting tape to the probe with 500 Newton force to have a good contact with the probe. When the trace on the Smith chart stabilizes towards the short point, I click the S calibration button in the GUI. To improve the quality of the short, I twist the tape under the probe. If I get a better short, I press the S button again. After short calibration, I press the Open button in the base system controller. Step 7. Prior to placing the load material on the platform, we need to improve the thickness measurement accuracy by zeroing the system. A gauge block with closest thickness to the load is placed on the platform. Here I use a 1 mm gauge block as an example. The corresponding size of the gauge is selected from the zeroing gauge choices in the base system controller window. Force is set to 200 Newton. The zeroing button is pressed. The platform moves up and software applies the zeroing correction, which accounts for mechanical offsets for further thickness measurements. After zeroing, the gauge block is removed from the platform. Step 8. I place the load on the lossy platform and close it with similar force used during zeroing. When the trace on the Smith chart is stabilized, the load calibration button is pressed. As the last step to complete the process, I press the Apply button to store the calibration. Open and short calibration for liquid measurement is similar to what we just did for solids. I only need to use a liquid as the load. To do that, I replace the lossy plastic platform with the black aluminum one and place a clean and dry petri dish on the platform for initial zeroing. I change the measurement mode to liquids and set the force to 20 Newton. I press the zeroing button to move the platform up and bring the petri dish into contact with the probe for zeroing at a very low force. Now I open the platform and half fill the petri dish with the load liquid. For DAC-TL2 1.2e and 3.5, we recommend to use DI water, and for DAC-TL2 12, 0.1 molar saline solution as the load. I measure the liquid temperature and enter it in the software. I type in 1 mm corresponding to 10 ml of liquid in the text box and press the Go to Distance button. Depending on the liquid volume, the distance should be set in a way that the probe is immersed in the liquid. As the final step, I push the Load Calibration button followed by the Apply button. Thanks for joining us today. If you have questions about the video or are interested to know more about our DAC system, just contact us at info@spag.swiss or contact your local sales representative.